a two-way ANOVA without replication. So this is whereby we want to see the influence of two factors. When we say two-way ANOVA, it means that we have two factors, and now whereby these factors tend to have different levels. Once they have different levels, so we want to see what is the influence of each factor on the results, so or on the dependent variable. In this case, we have our first factor here as fertilizer, and then the other factor is watering. So we want to see what is the influence of fertilizer and watering on the weight of a fruit. So these are just dummy variables. We want to see what is the influence of watering, either once a week, thrice a week, twice daily, or not even watering. And also the other side, we are here trying to see what is the influence of fertilizer on that is nitrogen. If you apply fertilizer containing nitrogen, or we apply calcium, or we apply phosphorus, potassium, or actually not applying any fertilizer, what will be the influence on the weight of fruit? So what we need to do is go to data analysis toolbar, which is here on top in Excel. So once you go to data analysis toolbar, you will find your data analysis tool pack, which is here. So this data analysis, if you've not installed it, follow our previous videos, you will see how to install data analysis tool pack. So go to data analysis. So data analysis, you'll have all these tools. We have the single factor all the way. So in our case, we are interested with the ANOVA, that is two factor without replication. This one does not have replication. So we are going to also see how with replication in the next video. But now we are trying to see without replication. So in the event we don't have replication, what is the expected result? So select two-way factor without replication, and then you click OK. So once you click OK there, input range. What is our input range? Our input range is we select all these data sets. So you select all the data sets here. Once you have selected all the data except this first row here, so you make sure the levels of fertilizer have been selected and all levels of water have been selected. And then here, this is where we had explained earlier about the labels. This tells us that yes, we do have variable, we do have labels as our in our first rows and column. This is the first column and this is the first row. So you tell Excel that these are not values, these are not values. Otherwise, if you don't tell it, you might not analyze this data. So select the labels there. So, and then output options, let's put our output options to be the next worksheet ply, whereby we want our results to be in the next worksheet, the new worksheet that is maybe sheet 2, whereby now we can be able to find our results. And just click OK. Great, now we have our results here. So once we have our results here, first things first, you will find that we need to understand our rows and columns. And if you come here, what is our row? These are the columns. The ones that are going down, ones are the columns. That is nitrogen, calcium, phosphorus. So our column is fertilizer. So you can even change. And then our rows are watering. These are the watering that the levels of watering. So change rows and put watering. Great. Now we can come and we can now interpret our results. So the first thing is about watering here. That is once a week, twice a week, thrice daily, and also no water. So you'll find among us all these, you'll find that when you go to the average here, you'll see that thrice a week recorded the highest weight of the fruit. So you'll find that as compared to all these, so definitely you'll say that watering thrice a week will result to higher weight of the fruit compared to daily or not even giving water once a week. But again, we come here to nitrogen. And then we come here to nitrogen, and for calcium, phosphorus, potassium, and no fertilizer. These are the levels of the fertilizer. Again, if you come here, you'll find that almost three of these tend to have almost equal weight, but phosphorus recorded the highest weight of the fruit. So we want to see, despite us having different values here and also having different values here, which are they significantly different? So let us say our significance level is 5%, which is equal to 0.05. So our interest is the p-values here. So you'll find that the p-value for watering is 0.00011189. So which is less than this. So the thumb rule is that if the p-value is less than the significance level, we definitely reject the null hypothesis. And what is our null hypothesis? Watering has more influence on the weight of the fruit. But in this case, we'll find that our p-value is less than the significance level. Therefore, we reject the null hypothesis and conclude that watering tend to have an influence on the weight of the fruit. And there is a significant difference across all the levels of watering. So depending on the type of watering you are going to get a different weight of the fruit. So let's go again to the influence of fertilizer. We find that our p-value is 0.6262. So which is higher than the significance level. So what do we conclude? We fail to reject the null hypothesis. And in this case, our null hypothesis was fertilizer does not have an influence on the weight of the fruit. Now we don't reject it, so we say that it's true, despite the type of fertilizer that you're using, be it nitrogen, be it calcium, phosphorus, potassium, or even not applying fertilizer, you're not going to get a different weight fruit. So weight fruit is not dependent on the fertilizer that you are using. Rather, it is dependent on the level of